Alright, so we were in the middle of working on this problem. I want to show you. Come on. There we go. Alright, notice it is in list 1, and we did the less than. She wants to see if her kids scored less than. Alright, and this is the information I got. I'm just going to write that information down. 498. Hard to tell, but okay. Sample standard deviation 1. We don't need the sample standard deviation because they told us the population deviation. All right, and so we need to compare this guy. Later, I'm going to show you how to do the P. We need to compare that Z to a critical value. So we have the Z test, and alpha is 0.1. So I'm going to go back and look at my little chart over here. So where? And it was less than, so it points to the left, and it's 0.1, so it's negative 1.28. So negative 1.28. Alright, I'm going to draw, and this guy, mean 1, 2, 3, 1, 2, 3. Alright, negative 1.28 happens like here, and it's shaded. Alright, we're going to figure out negative 1.14. So negative 1.14 is here. And it's in the white. And so since it's in the white, we're going to accept the hoe. Okay, we're going to accept the null. And so since we accept it, therefore there is enough evidence to accept that the mean is 515. Let's do another one. Alright, medical rehab reports average cost of rehab for stroke is $24,672. Alright, to see if the average is different at a particular hospital, the researcher selects 35 stroke victims and finds that the average cost is 26,343. The sample standard deviation, that's how we know to use z-test, 3251, and we're going to do alpha is 0.01. And if we concluded that the average cost of a stroke rehab at a particular hospital is different, right? So it is different, 24,672. All right, this is the HO, the HO, the null. This is the alternative, the claim, what we're trying to prove. All right, and so I'm going to go in my calculator, go to stat, calculate, z-test. All right, and I have just pure statistics. I don't have a list of data. So I'm going to go to stats, and then I'm going to try for U. I'm going to I'm going to do 24,672. Sample standard deviation is 3251. X bar is 26343. N was 35, and it's not equal to. Okay, make sure that your computer looks like it, or calculator rather. Alright. What happened? Has to push to do that again. Z-test. all of that. Type in there, calculate. All right, so I'm going to write that information down. I get Z is 3.04, E is 0.002. Again, I'm not going to show you the p-value way right this minute. I'm showing you this way. Excuse me. All right, we are, alpha is 0.01. It is a two-tailed test. 0.01, two-tailed. So look at that chart. 0.01. All right, two-tailed 0.01, and so we're at 258. Two-tailed, 258. Okay, so our critical value is plus or minus 2.58. All right, and so if we draw our curve, mean, 1, 2, 3. All right, and we're right here, negative 2.58. All of this is shaded. 2.58. All of this is shaded. All right, and we're at 3.04, positive. 3.04 is right there. All right, and it's in the shade. When it's in the shade, you reject that hoe. All right, reject the null. All right, so we can say therefore, there is enough evidence to accept. For rejecting this guy, we accept the other one. Accept that the cost is not 24,672. And really, we just accepted the fact that it wasn't that number. We don't know if it's greater than the number. We don't know if it's higher. If it's less than the number. It's just not that number. All right. So what we just did was the traditional way, where you compare the traditional way is you compare the you compare the critical value to the test value. All right, and that test value is either from the z-test or the t-test. All right, the p-value way, okay, by the way, p-value means probability value. That means what's the probability of that event happening. It's just another way to compare the data. All right, and so normally before they'll say alpha is 0.05 or alpha is 0.01, but as you're doing and analyzing the data, you actually calculate the p-value, and then you compare the alpha and the p-value. And these are the rules. If p-value is less than or equal to alpha, you reject the whole. Okay? So if p is less than alpha, all right, that's the Jesus fish. Okay, guys? If p is less than Jesus, obviously you need to reject the whole. I mean, come on. If p is greater than alpha, we're not going to reject it. We're not in the Word of God. I'm supposed to say that because we're in a Christian university, obviously. Okay, so we're going to go through the same things, except here, when I do my calculations, I'm going to, before we'd been writing that z down and looking at it, now I'm going to write the p down. All right, so here we are. Researcher claims wind speed, average wind speed is 8 miles per hour. A sample of 32 days has an average wind speed of 8.2. Standard deviation. All right, so population standard deviation, that's how we know we need to use the z-test, is 0.6, and alpha is 0.05. All right, I'm going to go through the exact same steps. I'm going to turn my calculator on. Okay, I'm going to go to stat, test, z-test. All right, oh, we didn't do, we need to know our null and our alternative. All right, this says Oh, we don't have enough information. All right, hang on. Let's do less than. All right, and so mu is less than 8. All right, so those are like what we're testing. Okay, so I'm going to go mu is 8. Sample standard deviation is 0.6. Population standard deviation, X bar is 8.2. And there are 32, and we're less than. All right, so I'm going to write both values down. C is 1.9. P is 0.97. Okay, so we are going to compare P and alpha. So P is 0.97, alpha is 0.05. And we need to figure out, is it less than, is it greater than, or maybe equal? I don't really see when it's equal. All right, and it's greater than. When it's greater than, hang on one second, let me double check I typed everything in correctly. 8.6, 8.2, 32, less than. Okay, so I'm going to, yeah, all right, so when it's less than, we reject the null. When it's greater than, we accept, there we go, the null. I got confused for a minute. So that means we accept this guy, so therefore we're going to write there enough to support that the mean is 8. All right, let's do another problem. Yeah, I want to do the p-value way one more time. And let's come here. So here, our p was 0.002, and our alpha was 0.01. Right, I need to compare those. So I'm going to compare P to alpha, 0.01, 0.002, and this guy's greater. And so the rule says when it points this way, you reject the hoe. And so we still get the same answer. Right, let's look here. Right, we got P is negative 0.13, and alpha was 0.10. So P versus alpha, 0.13. Positive, sorry, not negative. This is an equal sign. 0.13. Alpha is 0.1, and so this one's greater than. And so when it's greater than, you still accept the hoe. You accept the null. So it's the same conclusion. Here, let's look. We got P was 0.04, and alpha was 0.05. So we're going to compare P and alpha. So P is 0.04, alpha is 0.05, and so that one's greater. When it points this way, then you reject the hoe. You reject the null. All right, so we're still getting the exact same answer, whether we do it the traditional way or the p-value way, as long as our math is not wrong. Okay, so in the next video, I'm going to show you, this is for large samples, and the next video, I'm going to show you for small samples. All right, bye.